let's start 3.5 and okay, so this is actually a very straightforward section when we'll actually try to solve a given problem, which will be a quadratic function, okay? And we'll actually have inequalities in place of equations. So clearly, we know that for equations, let me write the equation for you. Let me write the function for you first. So that's the function for you. If we have a quadratic function like this, we know for an equation, if we set this to 0, we can use this formula, right? Plus minus the square root of the determinant over 2a. So that's only possible if we have an equation like this, okay? But what if we have inequality in place of equation? So for that, we want to use different properties. So first of all, let me quickly go over that. So if your function x squared bx plus c is strictly greater than 0, then we can actually draw the graph and find the answer, okay? So what I'll do, I'll actually take an example straight away so that it makes more sense to you guys, okay? So of this format, let me take the same example, x squared minus 2x minus 15, which is less or equal 0, okay? Okay, now, as I said, first of all, we'll actually graph this. We want to graph this function. So that means we'll actually write this as y equals x squared minus 2x minus 15. And if you are still wondering how can we easily graph this, if you remember, we can use the vertex and one other point to graph a quadratic function easily, right? Now, where is the vertex? So we can actually calculate it. Let's do that. The formula for that is b over 2a, and your value for b is -2, value for a is 1, so it will be 2 over 2, 1. So that's the first coordinate of your vertex. Now we want to see what's the functional value of that. So it would be 1 squared minus 2 times 1 minus 15. So 1 minus 2 minus 15 minus 16. So your vertex is at 1 comma negative 16. Okay. And if we just know one other value, we can actually graph it. But to know this precisely, the best way is to find the x-intercept and y-intercept. Okay, that's quite easy as well, right? So if we plug in y equals 0, we can get the x-intercept. So if I plug in y equals 0, this x squared minus 2x minus 15 will be 0. If we solve it for x using this formula, okay, value of b is -2. So -2 squared minus 4 times A is 1, C is negative 15 over 2 times 1. So this will be a positive 2 plus minus 2 squared is 4. This negative and this negative will become positive. So 4 times 15 is 60 over 2. 2 plus minus 60 plus 4 is 64 over 2. 60 square root of 64 is 8. So 2 plus minus 8 over 2. So all we have is 2 plus 8 over 2 or 2 minus 8 over 2. So our x-intercepts, 8 plus 2 is 10. 10 over 2 is 5. And 2 minus 8 is negative 4. And negative 4 over 2 is negative 2. Did I do it wrong?
Negative 6 divided by 2, so negative 3.
Oh, sorry, yeah, right. That's not negative 8. So 2 minus negative 8 is negative 6. Yeah, that's right. So that should be, oops, negative 3. Yeah. Okay, so our intercepts are clearly, as I plugged in y equals 0, so my intercepts are this. And secondly, if I just plug in x equals 0, I'll get my y-intercept. And that's quite easy to calculate. This guys will be 0. All I'll have is negative 15. So my y-intercept will be 0, negative 15. So now I know that this function will be concave up because the value of a is 1, which is greater than 0. So it will be concave up. It will be definitely of this shape. I know it will go past the x-axis in 2 points, which is this, and it will go through the y-axis at this point. So now we can draw this. So our x-intercepts are 5, 0. So let's say 1, 2, 3, 4, 5. That's our 5, 0. And the other one is negative 3, 0. So negative 1, 2, 3. So this will be our negative 3, 0. The other x-intercept. Also, we know the y-intercept is at 0, negative 15. So let's say that's my 5, 10, 15. So that's my 0, negative 15. And I know this is a concave up graph. So my intuition should say, also I know the vertex, right? Where is the vertex? Did I calculate it? Yeah. So my vertex is at 1, negative 16. So that's 1. That's negative 15. So that's 1, negative 16. That's the vertex. So there it will change its gear and change its direction. So this graph will look like this. Oops, sorry. It should go past that point like this. Yeah. Okay, yeah. This graph looks like this. Okay. That's your vertex. Okay. Now, if you remember, the graph said, what is the question again? Oops. Okay, so solve the inequality, which was x squared minus 2x minus 15 less than 0, less or equal rather. We want to solve it and graph it. okay, or rather graph the solution set. So already we have graphed the main function. Now we want to see for which values of x this remains true. That means the entire um, function is negative. Now, the beauty of graphing is you can actually eyeball it, right? So is there anyone, just don't look at the PDF or the file from MyMathLab, just look at this graph and see if you can find the values of x for which the function is at least 0 or less. You can actually eyeball it. Just try to do that. Can you? Daniel said -3 to 5. Why do you think it's -3 to 5? Can you, I mean, can you explain that using the graph? Yeah, Daniel, go for it.
Yeah, okay, that is the range between -3 and 5, whereby all the values of the equation are below or equal to 0.
Why do you think it's less than 0 using the graphical interpretation?
Yep.
Okay, so, okay, Pearson said -3 to 0. Okay, why do you think it's from -3 to 0? What's your explanation on this? You can try, as I said, even though it's wrong. Okay, so the main thing is what the question meant by having a value of 0 or less, okay, misunderstood the question. Okay, it's all right. So what it means by this, that it's actually below this guy, this straight line, this x-axis, because clearly we know that above this line, your value, your functional value is positive, and below this line, your functional value is negative. So when I say, or when the question says that it's actually 0 or less, that means the values, the functional values are actually either on this line or below this. So clearly, it's actually within this region where this entire function is on this line or even below that, you know, this entire functional value. Okay, so that's our answer. Okay, so now how do you write the answer? So if the question says write using solution set, you need to be very careful about it. Write using solution set, then you need to write it using the notation of a set, which is this, braces. So you can write x such that, we say this sign as such that, oops, x such that, that means x is set up in a way where x is, as you can see, it's from -3 to 5. So we'll say x is from -3 to 5. Okay. But if the questionnaire wants you to write using interval sign, then you can't use that. So once again, take a look at the question very carefully and see what the question wants you to do. So if it wants you to write using interval sign, then you need to, oh, sorry, it should be -3. Anyway, so you need to start from the lowest point on the left. You want to end at the highest point on the right, and if it's as it's included, you want to use this. If it was not included, we would have used parentheses, right? So that's your answer. One more thing in the question. The question said, graph the solution set. Okay, now what does that mean? So that's your solution set. That's only a single variable answer, right? There is no y, there is no functional values assigned to it. So that means instead of 2 coordinates, we'll actually use 1. That's the real number line. That's for x. So we'll start from 0. Let's say that's my 5. That's my -5. So this x is in between -3 to 5. So let's say that's my -3. So the solution set will be this portion from -3 to 5, including that, because our -3 and 5 was included. So this will be the solution set. Okay, any question from this?
So can we use the large bracket to show that from -3 to -5 to +5? Like,
Which one? Sorry, I didn't get your question.
I mean, can we use the large bracket like the ones we use here in the graph, like to show
This bracket?
this bracket? Then this, how do you call this? Like,
These are parentheses.
what about this? But the brackets. I'm talking about the brackets.
Okay, so you want to use for the solution set?
Yep.
So I'm not sure how can you use that for a solution set. Do you mean like this? Let me try. Maybe I have got what you're trying to say. Do you mean this? Using this?
Yeah, according to the signs that we are given, like it is less or equal. So,
Yeah, of course. Yeah, I got it. Yeah, you can do that. Yeah, but
yeah.
just make sure you are drawing this real number line.
Okay.
Yeah, you can do that. Yeah, sure.
Thank you. Got it.
Okay, any other question from, I guess it was the first problem for 3.5, right? Yeah, it was the first problem. Any other question from the first problem? Looks like no other questions. So as we have enough time, we can actually solve one more. As I said, we don't have, too much contents today, fortunately. So we can actually practice more problems. Okay, so let's try this. So instead of picking up a problem, okay, so I think what you can do is, okay, let me try example 2. I think it's a different one. Yeah, let me try this first. Then what I'll do, I'll actually give you a problem for practice, okay? But let me first try and solve example 2. Because you might get confused when you see that. I don't want you guys to get confused, okay? Okay, so let's say instead of a straightforward inequality, you have a problem like this, where your f of x is x squared, g of x is x plus 6, okay? You have a problem like this. So what you want to solve this inequality. In other words, x squared less than x plus 6, okay? You want to solve it. So the first question is, can we repeat the same process as we have done in problem 1? And the answer is Yes, we can do that. So we can change sides for this. We can write like this: x squared minus x minus 6 less than 0, right? If we change sides for this, we can get this, and this looks pretty similar to the first problem. So you can actually repeat the same process. What's the other option? In your PDF, you will see there is option 2 for it. So just quickly, I want to show that as well so that you don't get confused. So what you can do, you can actually graph two functions separately and then solve. Okay, that's another way to solve this as well. So we know the graph of x squared looks like this. Okay, that's 1, that's 2, that's 3. 1, 2, 3. Okay, and we can also graph this. What is the function again? X plus 6, is it? Yeah, x plus 6. We can also draw this function x plus 6 by just knowing the x and y intercepts. That's pretty easy. So if I plug in x equals 0, I get 6. So our y-intercept is 0, 6. If I plug in y equals 0, that means if I plug in g of x equals 0, I can get the x-intercept, which is -6. So our x-intercept is -6, 0. As we know these two values, we can actually graph this. So that's -3, -4, -5, -6. So that's one of the intercepts. And the other intercept is at 0, 6. So let's say that's 1, 2, 3, 4, 5, and 6. So that's another intercept. If we can just join these two, we'll get our, I think I need to extend this just a little bit. Okay, yeah. So we now have the graph of the two functions we are given. Okay, now we want to see the values for which this guy is actually strictly less than this. Okay, excuse me. Now again, can you just eyeball this graph and see the values of x for which this graph of x squared is actually strictly less than this graph of x plus 6? Can you see that? -3 to 3. Okay, I think you got it right in terms of the graph, as my graph is not exactly the exact graph. It's not drawn precisely because it's not a graph paper. So what it means actually, as I say, from the graph, what it actually means, this portion, this entire portion below this red line, do you guys agree with me? This entire region below this red line is actually strictly less than, because on the graph we can see this green portion, this green shaded area is actually below this red line, right? This red line is of course x plus 6. So all we want is x squared, the portion of x squared, strictly less than that guy. So your answer should be this green portion. Before going for the interval, are you guys with me? Does it make sense to you guys? That yes, the green portion is actually the part which is less than x plus 6. The part of x squared, of course, which is less than x plus 6. Is there anyone who want me to re-explain this? Why this is the area? Why this is the portion we are trying to find? Okay, so if it was precisely drawn, this intersecting point would have been actually at 2, at -2. So as I said, as Ryan is just eyeballing my graph, it does look like somewhere between 2 and 3. Anyway, that's not a problem as long as you understand it. So the right answer is from 2, and this other intersecting point will be at 3. So I apologize because this is not the exact graph again. I don't have a graph paper on my notepad. I could actually use that, but again, that will actually take a lot of time. As you have the actual graph on the PDF, you can actually eyeball it. Sorry. So the answer would be -2 to 3, and as it's not included, so this will be open, right? Even on the number line as well, if you start from -2, end at -3, +3, you can use that, as Daniel said, because this is open. If it was closed, you would have used this, or you can actually highlight it by, you know, kind of, what should I say? Maybe using a different color, or you can actually make it bold using your pencil if you're drawing it on paper. Anyway, so that's it. That's your answer for this particular problem. Now, any question from this? Anything? No questions at all? Okay, so I'll assign 3.5 today. It will be also due tomorrow. I'll just give you a question or two, maybe 3 at best from 3.5 for homework, so that you can finish it tomorrow. Tomorrow, before you join the lecture, of course, don't forget to start the quiz. It will be available from 2:30 to 3 p.m. Within this 30 minutes, you need to finish that in one sitting. You'll have a 15 minutes window. Don't forget to upload your work either in My Math Lab. You'll actually see the window will pop up where you can actually upload your work as an image. Don't forget to upload or keep that to image format. I mean JPG or maybe PNG, any sort of image format. Don't convert it to PDFs. Just keep it to image. You can upload it to that new window in My Math Lab. Just in case if you have any problem, you can also email it to me, okay? I'll assign it today. It will have at best 3 questions, maybe even 1 or 2 questions. It will be due tomorrow. Maybe I'll just give you one problem, just only single problem from 3.5, so that you can finish it within tomorrow. Okay, I'll assign it just after I finish this discussion. I'll assign it and probably give you 1 or 2 questions, and it will be due tonight, tomorrow at 11:59. Yeah.